Welcome back to the session. In this video, I am going to discuss about magnetic field due to a current carrying solenoid. Okay, so look at the definition here. Solenoid is defined as if n number of turns of an insulated wire is wound around a cylinder, then the resulting coil is called solenoid. Correct or not? So look at this diagram. Here we have a coil which contains n number of turns. Correct or not? So here the current I starts moving in this direction. Correct or not? Yes. So for understanding purpose, these n number of loops, I am taking for example 3 loops here. So this is my first loop, this is my second loop, and this is my third loop. Okay. So according to magnetic effects of electric current, whenever a current is flowing through the conductor, it produces the magnetic field, and the shape of the magnetic field is concentric circles. Clear? So let us assume in this first circular loop I amount of current is flowing. Similarly in second loop also I current is flowing. Similarly in third loop also I current is flowing. Okay, so according to magnetic effects of electric current, whenever current is flowing, definitely it produces the magnetic field. The shape of the magnetic field is concentric circles. Correct or not? So I'm taking reference points. This is my first reference point and this is my second reference point. Okay. Similarly, here in second circular loop also, this is my first reference point and this is my second reference point. Similarly, in third loop also, this is my first reference point and this is my second reference point. So here, due to the flow of current, the magnetic field was generated. The shape of the magnetic field will be concentric circles like this. Correct or not? Similarly, for second loop also, concentric circles. Similarly, in third loop also, you will get the same magnetic field like concentric circles. Correct or not? So I have 3 circles, each circle having some amount of current is flowing. Due to the flow of current, magnetic field was generated. The shape of the magnetic field is concentric circles. Now, according to solenoid means n number of circular loops, right? So if you add all these 3 loops, you will get solenoid, right? So look at this diagram. Yes, I added 3 loops. I got finally solenoidal shape, right? So at topmost point, the total shape of the magnetic field will be like a concentric circles. Similarly, at the bottommost point also, the shape of the magnetic field will be like a concentric circles. Correct or not? Because current I is flowing through the circuit from positive terminal to negative terminal. Okay, suppose if I am standing very near to the positive terminal here. Okay, 1 second. Yes. So this is my position. Whenever I am standing here, my in pace means first pace behaves as a south pole and last loop, that means this one, acts as a north pole. Okay, now I have south and north poles. Based on that, easily I can able to find out the direction of magnetic field. Okay, so according to Bohr magnet means magnetic field lines always flows from north to south outside. So here in this solenoid also, north pole is located here. So the direction of magnetic field is from north to south in this direction. Similarly here also in this direction. Okay. So now I'm going to erase all the diagrams. I will explain the actual diagram. Okay, just a second. Yes, thank you. Yes, now look at this actual diagram. Here south pole is present and here north pole is present. So, and compare this Bohr magnet also. Here we have north pole, here we have south pole. According to Bohr magnet, the magnetic field lines always flows from north to south outside the magnet. Correct or not? Similarly, in solenoid also, the magnetic field lines are moving from north to south outside the magnet. And what is inside the magnet? Inside the Bohr magnet, the magnetic field lines are moving from south to north. Similarly, in solenoid also, the magnetic field lines are moving south to north inside. So that's why I mentioned this point. The shape of the magnetic field of a solenoid is similar to Bohr magnet. That means Bohr magnetic field direction as well as solenoid magnetic field direction, both will be same almost. Okay, I hope you understand Still one more point is there. Look at the inside the solenoid, we have magnetic field lines, right? So these magnetic field lines are uniform and strong. So inside the solenoid, the magnetic field lines are strong. Okay, so this is about solenoid case. I hope you understand. If you really like my video means, please subscribe my channel Physics Hunt 3. Thank you.